Hi all, welcome to Anil Nair classes. Today in this class, we are going to discuss one of the most important concept from number system, that is product of two positive divisors. How to write a number as a product of two positive divisors. Before we start the concept, let us understand some important key points.
Important concept
Divisor.
from number system.
Suppose 12 is there.
Product of two positive
12 is
divisors.
divided by
How
3.
to write a number
3 fours
as a
are
product
12.
of two positive
Remainder
divisors.
0.
Before we start the class,
So, this 12 is called as a dividend. 12 is called as a dividend, a number which is getting divided.
Suppose
3 is called as a divisor.
12 is
3 is called as a divisor.
3 fours are
4 is called as quotient.
Before we start the class,
4 is called as quotient.
dividend.
0 is called as a remainder.
Dividend.
0 is called as a remainder.
Getting divided.
Now if you observe, 12 can be written as 3 into 4 plus 0. That means one important key point, 12 is nothing but dividend. Dividend is nothing but divisor into quotient plus remainder. Divisor into quotient plus remainder. Extremely important point when we are doing some basic problems. Dividend is nothing but divisor into quotient plus remainder. Now if you observe, 12 when divided by 3, remainder is 0. If the remainder is 0, then 3 is called as a factor of 12. 3 is a factor of 12. 3 is a factor of 12. Factor or a divisor of 12, both are synonyms. So wherever you get the word factor or divisor, both represents the same thing. That is, when that number is divided by this number, the remainder will be 0, right? Divisor of 12. 3 is a divisor of 12. I hope you understood the definition of divisor, right? Divisor means a number which perfectly divides other number. A number which perfectly divides other number. A number which perfectly divides other number is called divisor. Perfectly divides means a remainder should be 0. Perfectly divides means a remainder should be 0. In entire this class, I am only going to discuss in how many ways can you write a number as a product of two factors or product of two divisors. Extremely important concept. If you miss this class, you will find it very difficult to find the integral solutions of the questions of the form 1 by x plus 1 by y is 1 by 12, 2 by x plus 3 by y is 1 by 6. Once you know the basics class, you will be able to solve the questions in seconds. I hope first slide is very clear to you. What is the definition of a divisor? Divisor and factors both are synonyms. Divisor and factors are both are synonyms. Now, those of you who are listening to the class for the first time, please sit in the class with a notebook and a pen or a pencil. The way I am explaining the class, if you find one sentence of mine to be extremely important and I will star mark it, please write down in your notebook. Ensure that you sit in the class with a notebook and a pen or a pencil. Kindly do not take screenshots and think that you can refer it later. Screenshot is never a good way to learn mathematics, right? Watch the entire lecture so that all your doubts will get clarified. To get the maximum output from the lecture, it is advised that students should not skip the class in between, right? At the end of the session, you will be able to eliminate the use of pen and pencils and maximize your brain power more than mindless calculation. Still, in case if you got any doubts, feel free to send a mail at support@anilnairclasses.com. The background what you are seeing is one of my class pictures. Those of you who are listening to my class for the first time, I might have taken more than 1000 students in a class, minimum 500 times, and I carry myself an experience of 15 plus years in test prep industry. I was the South India academic head for Career Launcher, managing entire South India. I hope it is clear. Straight away we will get into the concept. Right. Now Most of the people already know it. We stand number 1 in Google reviews all over India. If you type Anil Nair classes Bangalore reviews, if you type Anil Nair classes Bangalore reviews, we are at a rating of 4.8 out of 5 with 3,643 plus students giving us as a rating of 4.8 out of 5. It's very difficult for other people to come closer by. I think the next best rating will be 10% of ours. Why it is, you will come to know as the class proceeds. Now, we will start the class. Product of two factors. This is the concept. Product of two factors or product of two divisors. Product of two factors or product of two divisors. Product of two factors. Concept. First we will write a sentence. Number of ways of writing a number. Number of ways of writing a number. Of writing a number as a product of two factors. As a product of two factors. Number of ways of writing a number as a product of two factors. There are two cases. We will do case by case. Case 1, which is an ordered pair. Case 1, which is an ordered pair. What do you mean by an ordered pair? The order in which you write the variables matters. Order also matters. That means A and B is quite different from B and A. A and B is different from B and A. That means 1 into 12 is different from 12 into 1. 2 into 6 is different from 6 into 2. Because in 2 into 6, first we are writing 2. In 6 into 2, first we are writing 6. Ordered pair. When to use ordered pair? If variables are present in the question. If variables are present in the question. If variables are present in the question, please make use of ordered pair. If the variables are not present in the question, make use of unordered pair. I will explain with an example so that it will be clear. Now, in that one, suppose if n is a perfect square, if n is a perfect square, two cases we will take. If n is a perfect square and n is a non-perfect square. N is a non-perfect square. Why these two cases? I will explain it in the next slide. Suppose let me take a perfect square 25. Please see the heading. Heading is, in how many ways can you write a number as a product of two factors? In how many ways can you write a number as a product of two factors? 25 is 1 into 25. Reverse is also valid. 25 into 1. 5 into 5. Reverse is also 5 into 5, so you don't need to write it again. So if you observe, 25 is nothing but 5 square. How many factors are there for this number? 5 power 0, 5 power 1, 5 power 2. Total 3 factors are there for this number. Factors for 25 are 1, 5 and 25. How many ways you got? One way, second way, third way. That means if n is a perfect square, number of ways of writing a number as a product of two factors, I got equivalent to number of factors. Let me take a non-perfect square. 12. 12 is nothing but 1 into 12, 2 into 6, 3 into 4. Because it is ordered pairs, reverse also matters. 12 into 1, 6 into 2 and 4 into 3. And 4 into 3. What is a non-12? 12 as a power of prime basis is nothing but 2 square into 3 power 1. How many factors we got for this number? Split all the powers of 2. 2 power 0, 2 power 1, 2 power 2. 3 power 0, 3 power 1. 1 into 1, 1 is a factor. 1 into 3, 3 is a factor. 2 into 1, 2 is a factor. 2 into 3, 6 is a factor. 4 into 1, 4. 4 into 3, 2. 3 into 2, 6. 3 into 2, 6 cases. What are that 6 cases? 1, 2, 3, 4, 6, 12. That means if you observe in this question, in ordered pair, even if I took perfect square or a non-perfect square, number of ways of writing a number as a product of two factors is always equivalent to number of factors. 25 number of factors are 3. 5 power 0, 5 power 1, 5 power 2, and I got exactly 3 ways. If I write 12, what are the factors of 12? 1 is a factor, 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, 12 is a factor. Total 6 cases I got. Even if you write a number as a product of two factors for a non-perfect square also, I got 6 factors. Extremely important conclusion. Extremely important conclusion. Conclusion is, if you see, we will write down and very important conclusion. Conclusion is, in an ordered pair, number of ways of writing a number as a product of two factors, A and B are factors of K. A and B are factors of K. A and B are factors of K. It is nothing but number of factors for K. Number of factors for K. In how many ways can you write K as a product of two factors in ordered pair? Ordered pair means ordering also matters, right? A and B are factors of K, number of factors for K. Number of ways of writing a number, number of ways of writing a number, number of ways of writing a number K, number of ways of writing a number K as a product of two factors, as a product of two factors. It is always a number of factors for K. It is always a number of factors for K. Extremely important point. This is in case of ordered pair. When to use ordered pair? If variables are present in the question. If variables are present in the question, please make use of ordered pair. Please make use of ordered pair. Let me take an example. A into B equivalent to 30. How many values A comma B will take? A into B equivalent to 30. A comma B, how many values? Is 30 represented as a product of two factors here? Yes. In how many values A and B can take? 30 is nothing but 2 into 3 into 5. 2 3s are 6, 6 5s are 30. In how many ways can you write? It is nothing but number of factors for K. Number of factors for 30 are 2 power 1 means 2 power 0, 2 power 1, 2 cases. 3 power 1 means 3 power 0, 3 power 1, 2 cases. 5 power 1 is 5 power 0, 5 power 1, 2 cases. 2 into 2 into 2. Total how many cases I got? 8 cases I got. Always remember, in ordered pair, wherever you find variables in the question, you make use of ordered pair, and in ordered pair, answer is always a number of factors for K. I hope it is clear, right? Now, in case instead of 30, 30 is a non-perfect square. 30 is a non-perfect square. Instead of 30, instead of 30, suppose if it a 144 is given, 144 does not matter. In ordered pair, whether it is a perfect square or a non-perfect square, answer still always be number of factors for K. 144 is 2 power 4 into 3 square. Totally how many factors I will get? 0 to 4 5 cases, 0 to 2 3 cases. Answer is nothing but 5 into 3 15. I hope ordered pair is clear to you. Again I am repeating the important point. Ordered pair is used when the variables are present in the question. In ordered pair, it does not matter whether the number is a perfect square or a non-perfect square. Answer will always be equivalent to number of factors. You can easily check whether a number is a perfect square or not if the power of that number is even number or 0. Now next case comes, what if it is an unordered pair? It is an unordered pair. Unordered pair. When to use unordered pair? Unordered pair. Unordered means the way in which you write the numbers does not matter. That means A comma B and B comma A both are same. Whether in unordered pair, unordered, ordering does not matter. Ordering does not matter. When to use this concept? This concept is used if variables are not present in the question. If variables are not present in the question, please make use of unordered pair. If the variables are not present in the question, make use of unordered pair. Case 1. Case 1. N is a non-perfect square. Case 1. N is a non-perfect square. Non-perfect square. Let me take that example. N is 12. 1 into 12, 2 into 6, 3 into 4. 4 into 3 cannot be taken. It is an unordered pair. 6 into 2 cannot be taken because it's an unordered pair. 12 into 1 cannot be taken because it's an unordered pair. Even though you got 6 cases, 3 of them are duplicated. Half of them will be duplicated. That means even though there are 6 factors, number of factors are 6. If you observe 1, 2, 3, 4, 6, 12, half of them are eliminated because the reverse is not possible. Number of factors by 2. If n is a non-perfect square, in an unordered pair, it is always a number of factors by 2. For example, n is nothing but 160. How to write a number as a product of two factors? As a product of two factors in unordered pair. Product of two factors in unordered pair. Product of two factors in unordered pair. 160 is nothing but 16 into 10. 16 is 2 power 4. 10 is 2 into 5, which is nothing but 2 power 5 into 5 power 1. Number of factors for 2 power 5 is 2 power 0 to 2 power 5. 6 cases. 5 power 1 is 5 power 0 to 5 power 1. 2 cases. Unordered divided by 2. Answer is nothing but 6. Answer is nothing but 6 cases. In ordered pair, there is a difference between a perfect square and there is no difference between perfect square and a non-perfect square. But in an unordered pair, there is a difference between what if the number is a non-perfect square and what if the number is a perfect square. Ordered pair, no difference. Directly it is number of factors. In unordered pair, there is a difference because we have to eliminate the duplicates. I hope in unordered pair, case 1 is clear to you. Case 2. Case 2. Case 2. If a number is a perfect square, if a number is a perfect square, if a number is a perfect square, which case we are doing? We are doing unordered pair. We are doing unordered pair. N is a perfect square. Suppose if I take n value 36. 36 is 1 into 36, 2 into 18, 3 into 12, 4 into 9, 6 into 6. 9 into 4 reverse we should not take. 12 into 3 we should not take. 18 into 2 we should not take. 36 into 1 we should not take. 1, 2, 3, 4, 5 cases. What are the factors of 36? Factors of 36 are, you write down in this order, you will get all the factors. 1, 2, 3, 4, 6, 9, 12, 18, 36. 3, 6, 9. So, how many? 36 is nothing but 2 square into 3 square. Totally how many we got? Totally number of factors. Number of factors we got it as 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factors we got it. What are that pairs that we got? One pair, second pair, third pair, fourth pair, remaining is 6 into 6. 5 pairs we got. That means answer is nothing but number of factors plus 1 by 2. Why this plus 1 by 2 we got? Here we got total 9 factors, first and last, second and second last, third and third last, fourth and fourth last. 4 we got, and there is another pair 6 into 6, which is nothing but root n into root n. Number of factors plus 1 by 2. It can also be number of factors minus 1 by 2. If you want to omit these cases, that means if root n into root n is excluded, you can take it as a number of factors minus 1 by 2. When will we exclude? 4 and 9 are distinct, 3 and 12 are distinct, 2 and 18 are distinct, 1 and 36 are distinct, 6 and 6 is not distinct. If a distinct word is there, if a distinct keyword is there, answer is number of factors minus 1 by 2. If distinct keyword is not there, we have to include root n into root n. So, if distinct is not present, please understand the subtle difference, otherwise you might lose that calculation and get the different answer. If a distinct keyword is not present, use number of factors plus 1 by 2. If a distinct keyword is present, use a number of factors minus 1 by 2. I hope it is clear. Again, I am repeating it carefully. In an ordered pair, if a number is a non-perfect square, it is straight away number of factors by 2. If the number is a perfect square, number of factors plus 1 by 2, number of factors minus 1 by 2, depending upon the question. It cannot be number of factors by 2. Why? Because if it is a perfect square always gives odd number of factors. You cannot take it as odd divided by 2. I will get it in decimal. Number of ways can never be in decimal. So, obviously, it cannot be number of factors by 2. Either it will be number of factors plus 1 by 2. Plus 1 means you are including one more case. What is that case? Root n into root n. Number of factors minus 1 by 2. You are eliminating one more case, which is root n into root n. I hope the idea is clear. I will take few examples so that it will be clear to you. Unordered pair. First one, case k equivalent to 360. Unordered pair means 360 is nothing but 72 into 5. 2 cube into 3 square into 5 power 1. 360 is a non-perfect square. 360 is a non-perfect square. Non-perfect square, answer is nothing but number of factors divided by 2. Number of factors is, for 2 power 3, there are 2 power 0 to 2 power 3, 4 cases. 3 power 2, it will be 0 to 2, 3 cases. 5 power 1, 0 to 1, 2 cases, divided by 2. 4 into 3 is 12. 4 into 3 is 12. I hope the idea is clear. Suppose if it is k is 144. K is 144. 144 is nothing but 16 into 9, 2 power 4 into 3 square, which is 12 into 12. Now if you observe 16 into 9. So 144 is a perfect square. If it is a perfect square, by default it will be number of factors plus 1 by 2. 2 power 4 number of factors is 5. 3 power 2 number of factors is 3 plus 1 by 2. 15 plus 1 16. 16 by 2 8. I hope second example is also clear. I hope you have understood the concept. In ordered pair, when to use ordered pair? If variables are present in the question, use ordered pair. If variables are not present in the question, use unordered pair. In ordered pair, it is always a number of factors. In unordered pair, it depends upon the nature of the number. If the number is a non-perfect square, it is a number of factors by 2. If it is a perfect square, it is a number of factors plus 1 by 2. If the keyword distinct is there in the question, it is a number of factors minus 1 by 2. I hope you got an idea. Once you understand this idea, then problem solving is a cakewalk. You will be able to solve the question probably in seconds. Now we will get into problem solving. All the questions are based on product of two positive divisors. Question: in how many ways 60 can be written as product of two positive divisors? Is variables present in the question? Variables is not present in the question. So if variables are not present in the question, this is nothing but unordered pair. This is nothing but unordered pair. First point. So 60 factorize 60. 60 is nothing but 4 into 3 into 5. 4 is 2 square into 3 into 5. If the number is a non-perfect square, 60 is a non-perfect square. So in unordered pair, if number is a non-perfect square, what will be the logic? Logic is nothing but number of factors divided by 2. Number of factors divided by 2. Number of factors for 60 will be 2 square means 0 to 2 3, 0 to 1 2, 0 to 1 2 divided by 2. 2 2 cancel, 3 2s are 6. I hope the idea is clear. Variables are not present in the question. Because variables are not present in the question, it is an unordered pair and it is a non-perfect square. In unordered pair, if it is a non-perfect square, answer is always number of factors by 2. So 2 square into 3 into 5, 0 to 2 3, 0 to 1 2, 0 to 1 2, 3 into 2 into 2 divided by 2. Answer is 6. Next, in how many ways can 100 be written as a product of two positive divisors? First of all, are the variables present in the question? Variables are not present in the question. If the variables are not present in the question, then it becomes an unordered pair, and we have to check the second condition. Is the number a perfect square or a non-perfect square? 100 is nothing but a perfect square. 100 is a perfect square. 100 is a perfect square. If 100 is a perfect square, so this will be 100 is nothing but 2 square into 5 square. 2 square into 5 square. So if it is a perfect square, what will be the answer? Answer is nothing but number of factors plus 1 by 2. Number of factors will be 0 to 2 3, 0 to 2 3, 3 into 3 plus 1 by 2, 9 plus 1 10, 10 by 2 5. Very easily, just by looking at a question itself, you without any confusion you will derive the answer if you have understood the basics. Next one, how many ordered pairs of positive integers satisfy the equation xy equivalent to 72? Are the variables present in the question? Check it out. Are the variables present in the question? If the variables are present in the question, then it becomes an ordered pair. In ordered pair, you don't need to check whether the number is a perfect square or not. Answer is nothing but number of factors. Answer is nothing but number of factors for a given number. 72 is nothing but 2 cube into 3 square. So number of factors for this number will be 2 power 0 to 2 power 3, 3 power 0 to 3 power 2, 0 to 3 4 cases, 0 to 2 3 cases, 4 into 3, answer is nothing but 12. I hope the idea is clear. If variables are present in the question, it is an ordered pair. In ordered pair, you don't need to check whether it is a perfect square or a non-perfect square. Directly it is a number of factors. Next one, how many ordered pairs xy of positive integers? I hope you have understood the difference between previous question and this question. I just gave one number which is a non-perfect square. I just gave another number which is a perfect square. Solution. Variables are present in the question. Yes, if variables are present in the question, then this case will become an ordered pair. Ordered pair. Anyway, it is given in the question. Even if it does not give, if variables are present in the question, it is an ordered pair. Ordered pair, it is nothing but number of factors. Ordered pair is nothing but number of factors. 144, which is 2 power 4 into 3 square. Number of factors, it is nothing but 2 power 4, 0 to 4, 5, 0 to 2, 3. 5 3s are 15. 5 3s are 15. I hope the idea is clear, right? It does not matter whether it is a perfect square or a non-perfect square. A slight change in the question. See the previous question, it is positive integers. See the previous question, it is positive integers. See the previous question, it is positive integers. Now, I changed the question. It is integers. It is integers. A very small change. Solution. First of all, are the variables present in the question? Yes, variables are present in the question. If the variables are present in the question, then it is an ordered pair. Then it is an ordered pair. In this ordered pair, till now we did positive integers. Positive integers. We got the answer it as number of factors. We did it in the previous problems, but now the question is integers. Integers means positive into positive, positive. Negative into negative is also positive. That means we will get, if it is an integer, I will get 2 times the number of factors. I will get 2 times the number of factors. I hope it is clear. Why? Positive into positive one case, negative into negative also another case. So 180. 180 is nothing but 36 into 5. 36 is 2 square into 3 square into 5 power 1. 2 square is 3. 3 square is 3. 5 power 1 is 2 cases. 18. 18 positive cases, 18 negative cases, 18 positive, 18 negative. Total I will get 36 for this answer. Why it is not a number of factors? Why it is 2 times the number of factors? Because the question beta, it is asking for integers. It is not asking for positive integers. Positive means 2 numbers positive, we would have got it. But it is asking for integers. I will take an example and I will show. I hope this concept is clear. Suppose I will take an example. 12 is there. 12 is nothing but 1 into 12, 2 into 6, 6 into 2, 12 into 1, or I will write it like this. 12 is nothing but 1 into 12, 12 into 1, 2 into 6, 6 into 2, 3 into 4, 4 into 3. These are all positive cases. Negative cases can be minus 1 into minus 12, minus 12 into minus 1, minus 2 into minus 6, minus 6 into minus 2, minus 3 into minus 4, minus 4 into minus 3. So if you see, here I got For 12, 12 is nothing but 2 square into 3 power 1. 3 into 2, total 6 ways. 1, 2, 3, 4, 5, 6. I got 6 positive cases. I got 6 negative cases. 6 positive, 6 negative. Total cases are 12. I hope it is clear. Be very, very careful. Read the question twice. Otherwise, you might end up doing silly mistake. If it is an integers, I will highlight this point. If it is an integers, I will get 2 times the number of factors. If it is an integer, I will get 2 times the number of factors. I hope the point is very clear. There is a difference between positive integer and integer. Integer is not only positive but also negative, right? Anyway, 0 case is not taken. Again, how many ordered pairs of integers, not positive integers? Solution. Are variables present in the question? Yes. If variables are present in the question, then it is considered to be an ordered pair. Ordered pair. In ordered pair, if I have to write it as a product of 2 integers, if I have to write it as a product of 2 integers, it is nothing but 2 times the number of factors, 2 times the number of factors. 784 is nothing but 28 whole square. 28 is 2 square into 7 whole square, which is nothing but 2 power 4 into 7 square. 2 power 4 into 7 square. 2 into number of factors, 2 into number of factors for 2 power 4 is 0 to 4, 5, and 7 power 0 to 2 is 3. 2 5s are 10, 10 3s are 30. 10 3s are 30. I hope it is clear. 2 power 4 will be 0 to 4, 5 cases. 7 power 2 will be 0 to 2, 3 cases. I hope the concept is clear. Again I am telling you, be extremely cautious, right? Otherwise you might get half of the cases. Integers, it will be double. Positive integers, it will be the same number. Now, another very beautiful concept. If for n equivalent to 72, find the number of ways in which n can be written as a product of 2 positive integers such that both are odd, both are even, one is odd and another is even. Very, very good question. Concept. 72. 72 can be written as 1 into 72, 2 into 36, 3 into 24, 4 into 18, 6 into 12, 8 into 9. First thing, variables are not present. If variables are not present, this case is an unordered pair case. This case is an unordered pair case. This is the first observation. Now, n is 72. 72. First case 1. Both are odd. Both are odd. Both are odd means odd into odd. What is odd into odd? Odd into odd is an odd number, but 72 is an even number. 72 is an even number. Odd into odd is odd. So the first one answer is 0. First one answer is 0 because he is telling product of 2 positive divisors. Product of 2 positive divisors, right? So if one divisor is odd, another should be odd. Odd into odd is odd, but 72 is an even number. First one answer is 0. Second one. Second one. Second case, if you see. Second case. See the second question. Let us go step by step. Everything will be clear to us. Second one. What is the second case? Both are even number. N is 72. Both are even number. both are even number. That means first even number can be 2k1, second even number can be 2k2, both are even, equivalent to 72. I hope it is clear. K1 into K2, 72 by 4, which is nothing but 18. 18 is nothing but 3 square into 2 power 1. First of all, it is an unordered pair and 18 is a non-perfect square. So, answer is nothing but number of factors divided by 2. So, 3 into 2, 6, 6 divided by 2, 6 divided by 2, 3. I hope it is clear. Both are even number means one even number is 2k1, another even number is 2k2. Odd into odd, first one answer is 0, second one answer is 3. I hope the idea is clear. Third one. Got the idea right? Third one. Just all are conceptual related. This topic is where you require a teacher intervention. Third one. One is odd, another is an even number. Odd number into even number, it should give me 72. 72 is nothing but 2 power 3 into 3 power 2. It should be odd number means it can be 3 power 0, it can be 3 power 1, it can be 3 power 2. Am I right? I cannot take 2 power 1, 2 power 2 because 2 power 1, 2 is an even number. 2 square 4 is an even number. So, this can be 2 power 3. This can be 2 cube into 3 power 1. This can be 2 cube. Are you all with me? So, it is nothing but 1 into 72. This is 3 into 24. This is 9 into 8. Total how many cases we got? 3 cases. What are the 3 cases? Odd means 3 power 0, 3 power 1, 3 power 2. 3 power 0, 3 power 1, 3 power 2 is nothing but odd factors. So, third one answer is total number of odd factors. Very easy if you know the concept. If you don't know the concept, you will say that this question is difficult. Most of the students only study the basics and they expect the questions to come from basics, right? You have to know from basics and you have to go to the advanced level. Both are odd, not possible. Odd into odd can never be an even number. First option, it is 0. Both are even number. Even number is of the form 2k1. So, 2k1 into 2k2. It is 72, k1 into k2 is 18. One is odd, another is even. Odd means push 3 power 0, 3 power 1, 3 power 2 right into an odd side. They are nothing but the odd factors. 1, 2 and 3. I hope the idea is clear. We will do more and more problems so that it will be clear to you. N is 29. N is 29. Find the number of ways in which N can be written as a product of two positive divisors such that both are odd, both are even, one is odd, another is even. First one, see here. Second one first we will do. Both are even number. Both are even number. That means even number into even number. Even into even, I will get an even number. But the question is 29. It is an odd number. So, answer is 0. Answer is 0. Second one, I hope it is clear, right? Third one. One is odd, another is even. If one is odd, another is even. One is odd, other is even. If one is odd, other is even. Odd number into even number. Any number multiplied by an even number, it will become an even number. So, answer for this question is again 0. Answer for this question is again 0. I hope second one, it is clear, right? Even into even is even, right? One is odd, another is even. Odd into even, it has to be an even number. First one, both are odd. Both are odd. So, if n is 29, it can be written it as 1 into 29 and 29 into 1. So, but variables are not present in the question. If variables are not present in the question, this is nothing but unordered pair. Unordered pair number of factors divided by 2. Reverse cannot be taken. Answer is 1. I hope the idea is clear. Answer is 1. Just look at the question. If it is an odd number, it can only be an odd into odd. If it is an even number, it will be odd into even, or it could be even into even. That you check it out. I hope it is clear, right? Now, one important n equivalent to 42. Now, one concept. The n is a natural number. N is a natural number. Listen carefully to this concept. If n is a natural number, it can have these cases. Either it will be divisible by 4, or it gives a remainder 1, or it gives a remainder 2, or it gives a remainder 3. It gives a remainder 1, it gives a remainder 2, it gives a remainder 3. If I take the second case, both are even. Both are even number means if one number is 2k1, another number will be 2k2. So 2k1 into 2k2, that means it is divisible by 4. If both are even numbers, 4a plus 1, answer will be 0. Yes or no? Why? Because right hand side will be divisible by 4. Both are even numbers, right? 2k1 into 2k2, 4a plus 2, answer will be 0. 4a plus 3, answer will be 0. I hope it is clear. If n is a natural number and the right hand side other than divisible by 4, it is gives a remainder 1, gives a remainder 2, gives a remainder 3. Answer will be 0 for the case both are even numbers. How can it give an answer if both are even numbers? One is 2k1, another is 2k2. 2k1 into 2k2, it has to be divisible by 4. It cannot give a remainder 1, it cannot give a remainder 2, it cannot give a remainder 3. So both are even. Answer is 0. Extremely important point, please make a note of it. Please make a note of it. Other than the number which is divisible by 4, it gives a remainder 1, it gives a remainder 2, it gives a remainder 3. All the cases both are even, answer will be 0. Both are even, answer will be 0. Now let us solve the question. This is just an idea. Now, variables are not present in the question. If variables are not present in the question, if variables are not present in the question, then it is an unordered pair. Then it is an unordered pair. First case, both are odd. Both are odd. Both are odd. If both are odd, what is odd into odd? Odd into odd is always an odd number. But the value given in the question is 42. So the first question answer is 0. Second question, both are even. Both are even means, already we discussed this. If both are even, one is 2k1, another is 2k2. Right hand side should be divisible by 4. 42 is not divisible by 4. Answer for the second question is 0. Third question. One is odd, another is even. So 42. 42 is nothing but 2 into 3 into 7. 2 into 3 into 7. That means here it is odd into even. Here I can take odd numbers. Here odd numbers that can be taken are nothing but 3 power 1, 7 power 1. Yes or no? So it is 3 into 14. It is 7 into 6. 42 can be written. If I write down as a product of two factors, 1 into 42, 2 into 21, 3 into 14, 7 into 6. Am I right? So 42 is nothing but 2 into 2 into 2 into 2, 8. Now you can also write it as 3 power 1 into 7 power 1 into 3. Another case, you can also write it as 1 into 42. It is simple, nothing but number of odd factors for this number. 1 is odd means odd only will be fixed. Either you can fix 1, or you can fix 3 power 1, or you can fix 7 power 1, or you can fix 3 power 1 into 7 power 1. So these are nothing but total number of odd factors. Total number of odd factors, which is nothing but 4. I hope it is clear. Second question. These are all very, very good questions which are generally not given in the regular textbook. Students will just read one concept and they think that the concept is covered. I will go to such a level where you can start predicting these questions. All these videos are available to an enrolled students portal. Non-enrolled students, you can call us and buy the course in case if you love this structured way of learning. I hope third point is clear. Another one, n equivalent to 15,9. Case 1, both are, okay, case 2 and case 3 we will do. Both are even. Both are even is nothing but one is 2k1, another is 2k2. That means answer should be divisible by 4. 59 is not divisible by 4. Second option is 0. Third one, it is nothing but an odd into an even number case. Any number multiplied by even number, answer will be an even number. But the question is 15,9. Third case, answer is nothing but 0. First case, which is nothing but odd into odd. Odd into odd is nothing but 1 into 15,9. 59 into 1. Reverse case cannot be taken. Why? Because if variables are not present in the question, if variables are not present in the question, then it is an unordered pair. In an unordered pair, answer is nothing but number of factors divided by 2. So 2 divided by 2. Third one, answer is 1. I hope the idea is clear, right? All these cases why I took. 59 is 4 into 14 plus 3, 4k plus 3, 4 into 10 plus 2, 4k plus 2, 4 into 7 plus 1, 4k plus 1. Next case is 4 into 18. Any number when divided by 4, it gives perfectly divisible, it gives a remainder 1, it gives a remainder 2, it gives a remainder 3. All the 4 cases which we discussed. All the 4 cases which we discussed. I hope the concept is clear, right? So what are the cases which we discussed? Odd into odd we discussed. Odd into even we discussed. Even into even we discussed. Even into even this. In this even into given, if the right hand side is of the form 4k plus 1, or if the right hand side is of the form 4k plus 2, or if the right hand side is of the form 4k plus 3, answer is always 0. Answer is always 0. Right hand side is of the form 4k plus 1, 4k plus 2 or 4k plus 3. Answer is always of the form 0. I hope it is clear. If this is for this case, odd into even, odd into even, if number is an odd number, number is an odd number, number is an odd number, decompose the number as a product of odd into odd, odd into odd. If it is an odd into an even case and number is an odd number, odd into even will give an odd number. So answer for this question is again 0. It all depends upon the value the n take. You don't need to remember it like this. You just see the question and go step by step. You will get the answer. Next one. N is a 525. Find the number of ways in which n can be written as a product of two positive divisors such that both are even number. Second case. Even number into even number. Any number multiplied by an even number, answer will be an even number. In this case particularly it is divisible by 4 and it is an even number, but 525 is an odd number, so answer is 0. Answer is 0. Third case it is odd into an even number. Any number multiplied by an even number, answer will be an even number. But the right hand side value is 525. Again the third case, answer is 0. First case, both are odd. Odd into odd. Odd into odd. If the right hand side is an odd number, it is nothing but odd into odd. So variables are not present in the question. If variables are not present in the question, answer is nothing but number of factors divided by 2. Number of factors divided by 2. 525 is 5 into 105. 5 into 21 into 5. So it is 3 into 7 into 5 square. So 3 sevens are 3 into 7 into 5 square. So number of factors will be 2 into 2 into 3 divided by 2. 2 3s are 6. I hope the concept is clear. Idea is clear, right? Now, in how many ways can 100 be written as a sum of one or more consecutive integers? Now, I will tell you the concept by example. Concept by example. Suppose if I take 15, how can I write 15 as a sum of 2 or more consecutive 1, 2, 1 plus 2 plus 3 plus 4 plus 5. Is it clear? Sum is 9, 12, 14, 15. Or you can also write it as 7 plus 8. You can also write it as 4 plus 5 plus 6. 9 plus 6 is 15. So 15 is nothing but 3 into 5. How many odd factors are there for this number? Number of odd factors are 4. Number of odd factors are 4. How many ways I got? 3 ways I got. Please write down this one. Number of ways. I will also give you the proof. Number of ways of writing a number. Number of ways of writing a number as a sum of 15 can be written as 15 as a sum of one or more consecutive integers. One or more consecutive integers. It is nothing but number of odd factors. Number of odd factors. Please write down this extremely important point. Number of ways of writing 100. This we are doing it for positive integers. This we are doing it for in number of ways of writing a number as a sum of one or more positive integers we are doing. Then we will do total number of integers. It is nothing but number of odd factors. First we will do it for positive integers, then we will come to integers. I hope the concept is clear. Sir, why it is a number of odd factors? I will give you the proof in session 2. I will give you the proof in session 2. Now if I look at this question, suppose if I add positive integers here, first we will start with basics. 100 is nothing but 2 square into 5 square. Total number of odd factors is nothing but 5 power 0, 5 power 1, 5 power 2. So number of ways of writing a number as a sum of one or more consecutive positive integers. Consecutive positive integers. I am only first taking consecutive positive integers. It is nothing but 3, which is nothing but total number of odd factors. Total number of odd factors. Total number of odd factors. I hope the idea is clear. We will do it for integers in the next one. Suppose, okay, already it is there. 100 is nothing but a sum of one or more consecutive positive integers is nothing but total number of odd factors, which we got it as 3. Right? Now there is this consecutive integers. Do not miss the session 2 live class of mine. I am going to explain why sum of one or more consecutive positive integers is total number of odd factors with proof. With proof which I am going to explain. I hope this is clear. Key points revisited. What is that we discussed? First we discussed the definition of a divisor. First we discussed definition of a divisor. Then we discussed ordered pair. Ordered pair. Ordered pair. Number of ways of writing a number as a product of two divisors. As a product of two divisors is nothing but a number of factors. Another concept which we discussed. In an unordered pair, third concept, in an unordered pair, product of two divisors, two cases we discussed. If n is a perfect square, if n is a perfect square, number of factors plus 1 by 2, number of factors minus 1 by 2. If n is a non-perfect square, if n is a non-perfect square, number of factors whole divided by 2. I hope these three important concepts which we discussed all are based upon this one. Let us revise all the important things that we discussed. Product of two positive divisors. Variables are not present in the question, it is an unordered pair. Variables are not present in the question, it is an unordered pair. Variables are present in the question, it is an ordered pair. It does not matter whether the number is a perfect square or not, number of factors. Variables are present, number of factors. Variables are present, number of factors. Variables are present, and it is an integer, positive into positive, positive, negative into negative also is positive 2 times. Both are odd, both are even, one is odd, one is even. 4 cases I discussed. Number divisible by 4. Number when gives divided by 4, remainder 1. Number when divided by 4, remainder 2. Number when divided by 4, remainder 3. All the cases which we discussed. So all the cases then we discussed, sum of one or more consecutive positive integers. It is nothing but total number of odd factors. Why? Why it should be total number of odd factors? I will again take the session in session 2 live. Session 1, session 2, session 3. All the 3 sessions are based on product of two divisors. Do not miss any class of mine. One class if you miss, probably 5 to 6 concepts you will miss it and you will fumble in your examination. Listen to my class, absolutely no doubt you will get it.